we know what is group, what is subgroup, right? And also we know the left cosets and right cosets. See, G, suppose G is a group, right? G is a group, and say H is a subgroup of G. So then what we have, first of all, H is a subset of G, and H is also a group with respect to the same binary operations, a binary operation defined on G. Now let some A in G, then you look at this set AH, then this AH is called the left coset of H induced by A, and similarly we can talk about HA. So this is what it is, a right coset of H. And what is this set? It is AH where H in H, and this set is HA where H in H. So we know this thing. So before Lagrange's theorem we had discussed this thing, right? And also we have defined one more set, that is AHA inverse. So this is what AHA inverse where H in H. So this is called left coset, this is a right coset. So both these are what? It is a subset of G. It is a subset of G. We can't say that it is a subgroup. In some cases it becomes subgroup. And also we know, and that is what, if A is in H, if and only if H is a subgroup of G. We have proved this result. So every left coset or right coset may not be the subgroup of G. It is a subset. But if you consider element A from subgroup H and you prepare a left coset or right coset, then it becomes a subgroup. And this is also one set, it is also important set, AHA inverse, it is this one, and it is also a subgroup of G, subset of G. Okay, so we know what is subgroup, but today we will discuss special types of subgroup, that is called normal subgroup. So what is normal subgroup? So if H is a subgroup, H is a subgroup of G, and if you consider any A belongs to G, then you consider left coset and right coset, then AH and HA, what can be said about these two? So are they always equal for every A in G? Is this true? So answer is no. This is not true in general, right? Sometimes this may happen that these two are equal, but we have some examples in which these two things are not equal. So the subgroup H of G for which every left coset is same as right coset, that type of subgroup is called normal subgroup. So let us first of all define. So definition, let H be a subgroup of G, then H is called a normal subgroup of G if AH is equal to HA for all A belongs to G. That is, for every left coset and right cosets are equal, then we say that the subgroup H is normal subgroup of G. If H is a normal subgroup of G, then we write H like this. H, this is left headed triangle, it is like this triangle, right? So for subgroup we just use this sign, less than or equal to. But if my H is normal, then we will use to write H is a subgroup of G, but it is a normal subgroup of G whenever H is normal in G. Okay, so this is just notation. Now once we define that every left coset should be equal to right coset, then we say H is normal. So we should have one example also, that for a group and it is a subgroup H, and for that it has left coset and right cosets are different. So let us see one example. So you consider you consider S3. G is my S3. So what is S3? S3 is one identity element, then it is 1 2 1 3 and 2 3 and 1 2 3 and 1 3 2. So these are 6 elements, 3 4 5 6, 6 element in S3. Now you consider H. H is equal to 1, and see 1 2 1 2 is what? 1 2 is a transposition, so its order is 2, or you may say it is 2 cycles, so its order is 2. So you consider one identity and 1 2 order element, then this will be what? This will be a subgroup of S3, right? Now you consider A is equal to 1 2 3, and it is an element of S3, right? So this is my G is equal to S3. H is a subgroup of G. Now you consider one element from G and you look at AH. So AH will be what? It is 1 2 3 H. So 1 2 3 H is what? You multiply every element of H by 1 2 3. So 1 is identity. So 1 2 3 into identity is 1 2 3, and 1 2 3 1 2. So this is what? It is 1 2 3, and 1 2 3 into 1 2 is what? 1 goes, you start with 1, say. So 1 goes to 2 and 2 goes to 1, so stop. Now 2. So 2 goes to 3 and 3 goes to 3. Now 3 goes to 1 and 1 goes to 2, so 2. So it is just 2 3, and 1 into 2 3, so 1 is identity, so no need to write, so let us just remove it. So AH is this one. Now what is HA? So let us find HA. So HA is what? H into 1 2 3, that is right coset. So it is what? You just multiply every element of H by 1 2 3 from right. So 1 into 1 2 3, it will be 1 2 3 because 1 is identity. Now 1 2 into 1 2 3. So let us see what is this. So it will be 1 2 3, and here 1 goes to 2, 2 goes to 3. Now 3 goes to 3, 3 goes to 1, so stop, and left is just 2, 2 goes to 1 and 1 goes to 2, so it is just 2, but 2 is identity, so no need to write this one. So it is this thing. So here you can see AH is 1 2 3 and 2 3, and here HA is 1 2 3 and 1 3. So therefore this AH is not equal to HA. So here what we have? H is a subgroup of S3, but H is not a normal subgroup of S3. वो normal नहीं है, वो just subgroup है, but it is not normal. So here we have one example in which we have a subgroup of a group, but its left coset and right cosets are not equal. So that's why this notion is important. Okay, if you have a subgroup, if you have a group, and if you have a subgroup, and if all left coset and right cosets are equal, then that type of subgroup is known as normal subgroup. See, one observation. See here, S3 is what? S3 is non-abelian. S3 is non-abelian. Now, if suppose G is abelian, G is abelian. Now you consider H is a subgroup of G. Now you consider any A belongs to H. A belongs to G, and you look at AH. So AH is what? A into H, where H in H. But my G is what? G is abelian, right? So A is an element of G, H is an element of H, so H is also element of G. So A and H both are elements of G. So this AH can be written as HA, because AH and A and H will commute for all H belongs to H, but this set is what? It is HA. So what I have proved, AH is equal to HA for all A belongs to G, means every left coset of H and every left coset and right coset are equal. So it means what? H is a normal subgroup of G. So what we have proved, if my G is abelian and H is a subgroup of G, then it is normal. So every subgroup of abelian group is normal. So we have one class, and that is what? An abelian group. So if you consider any subgroup of abelian group, then it is normal, right? So no need to worry about whether your subgroup is normal or not for the abelian group. So if my group G is non-abelian, then we have two cases, that whether my subgroup is normal or not. Here we have one example. S3 is non-abelian, its subgroup, it is not normal, but we cannot say that every subgroup of a non-abelian group is not normal. No, we have some normal subgroup, we have some subgroups of that normal subgroup, and they are normal also, and we will see. So first of all, we have, this is the concept of normal subgroup. Okay, so now now let us characterize this normal subgroup. So about a normal subgroup, we have so far what? Just definition. कोई मुझे ग्रुप दिया है, उसका सब ग्रुप दिया है और मुझे चेक करना है कि ये इसमें नॉर्मल है कि नहीं, देन आई हैव ओनली tool is what? It is just definition. So what I have to do, I have to check every left coset. You just start with a left coset and you check whether it is also its corresponding right coset are also same or not, equal or not. So that is the only tool. But let us characterize normal subgroup. So we have this result. Theorem. Let H be a subgroup of G. Then H is a normal subgroup of G if and only if, this symbol means H is a normal subgroup of G if and only if X inverse is a part of H for all X in G. मेरे पास कोई सब ग्रुप है H G का, वो नॉर्मल सब ग्रुप है, then it means it will satisfy this condition, and if my subgroup H will satisfy this condition, then my group will be subgroup will be the normal subgroup of G. So we will prove this. Okay, so before going to prove this, let me just analyze this thing. See, X inverse is a subset of H. What does it mean? इसका हर एक एलिमेंट इसमें होना चाहिए. Now ये, if I consider X inverse, so then this set is like what? It is X inverse where H belongs to H. तो ये सेट का कोई भी एलिमेंट इस फॉर्म का है, मतलब कि ऐसा हर एक एलिमेंट H में होना चाहिए. तो ऐसा एलिमेंट मीन्स ओके, and this condition is true for every X in G. So this condition for every X belongs to G, it means what? इसका हर एक एलिमेंट इसमें होने चाहिए. तो इसका एलिमेंट कैसा है? It is like X inverse where for all H in H it is a subset. This is a set and this is a set, so we have subset, but now I have replaced this set by its element. So now this is belongs to H for all X belongs to G. मतलब कि मेरा जो कोई ग्रुप है, लेट अस सी बाय फिगर, दिस इज माय G, दिस इज माय H. ये H मेरा G का सब ग्रुप है. तो ऐसी कंडीशन हो रही मीन्स व्हाट, यू कंसिडर एनी एलिमेंट H फ्रॉम H एंड एनी एलिमेंट X फ्रॉम G. तो ये X के लिए मेरे पास दो चॉइस है, आइदर X विल बी आउटसाइड H और X विल बी इनसाइड H. नाउ यू कंसिडर दिस टाइप ऑफ एलिमेंट X H X inverse, X H X inverse. So that element must be in X H X inverse must be in H. See, suppose X मेरा बाहर है तो X H X inverse इसके H के अंदर आ जाए, ऐसी कोई गारंटी नहीं है if my H is just a subgroup. But if it is a normal subgroup, then this thing will happen, and if this thing will happen, then it will be normal subgroup. So we will prove this thing. Okay, so in short, this condition X H X inverse subset H for all X belongs to G, it is equivalent to this. So these two things are equal. So what I did here, I have just replaced this set by its element. So if I replace this set by its element, then this subset becomes belongs to, and here H is a set, that's why it is a subset. So I here replace H by its arbitrary element, so it becomes belongs to. So if I extend this result, then this one is equivalent to what, X H X inverse belongs to H for all X belongs to H, and for all for all H belongs to H, and for all X belongs to G. तो इसका मतलब क्या हुआ, सी कि यदि मैं ये प्रूव कर लेता हूँ दिस थिंग, तो ये तो इसके इक्विवेलेंट है, अभी हमने देखा, राइट. तो मतलब ये दोनों प्रूव हो गया इक्विवेलेंट, then automatically these two are equivalent, so these two things are also equivalent. And for to prove that my subgroup is a normal or not, we will use this characterization that H is a normal in G if and only if this thing happened, and if this thing happened, then my H is normal. So first of all, let us prove this thing. So proof. So first let us assume that H is a normal subgroup of G. So my claim is what, X H X inverse. Okay, H is a normal subgroup of G. So by definition, up to so far we have just definition. So therefore H is equal to HF for all A belongs to G, left coset equal to right coset. Now my claim is what, X H X inverse is a subset of H for all X belongs to G. So you take let Y belongs to X H X inverse, इसमें से कोई एक एलिमेंट ले लो, Y belongs to X H X inverse. तो ये Y कैसे दिखेगा, Y is equal to X H X inverse for some H in H, right. So it means what, Y X, you multiply X both side from right side, so it is X H X inverse X is identity, or you may say X comes this side. So now this is what, see X H, so X H will be the element of X H because H in H. So X H is an element of left coset X H, but my H is normal, so every left coset is same as right coset. So X H is a left coset, so it is same as H X. So this Y X is an element of what, therefore Y X is an element of H X. तो ये Y X कैसे दिखेगा, Y X is equal to some H1 into X for some H1 belongs to H. So we are in group, so left cancellation or right cancellation law holds, so X X will get cancelled, or you multiply both side by X inverse, so we have just Y is equal to H1, and H1 is what, it is in H. So what we have proved, Y belongs to H. So Y, we have started Y from where, X H X inverse, and now it is in H, so it is a subset of H. So my claim holds. So one way is clear. Now conversely, now you assume that this x h x inverse is a subset of H for all x belongs to G. Now my claim is what? H is a normal subgroup of G. So claim is what? H is a normal subgroup of G. So for that, what I have to prove? Every left coset is same as right coset. So you start with let A belongs to G. Now I will show that AH is equal to HA. So you take one element from here. So say X belongs to AH. तो ये X कैसे दिखेगा? So X will be is equal to A into H for some H in H. Okay. So now what I want to prove? Yes. So this is what X. Now you multiply both sides by A inverse on right. So X A inverse is what? AH A inverse. Now I have this thing, so I will use this thing. So for that I need X H X inverse. So AH A inverse. So AH A inverse is what? It is an element of AH A inverse. Correct? But AH A inverse is a subset of H, because XH X inverse is a subset of H for every X in G. So here my X is A and A is already in G, right? So AH A inverse is a subset of H. So what I have proved? X A inverse is an element of H. X A inverse belongs to H. तो ये X A inverse कैसे दिखेगा? Is equal to some H1 for some H1 belongs to H. See, for this H, and I have used somewhere here H, so there is nothing to common or nothing, there is no relation between this H and this H, because already part is changed, part of the proof is changed. And here also I have used H1, so there is nothing, this H1 and this H1 are common. It is nothing like that. This H1 is some H1 and this H1 is, it may be different. Okay, so now this is what? It is X is equal to H1A. But this H1A is what? It is an element of HA. So what I have proved? X belongs to HA. So this AH, X is from AH, and I have proved it is in HA. So AH is a subset of HA. So similarly you start with X belongs to HA, and by the same argument you can prove that HA is a subset of AH. So similarly AH will be a subset of HA. So therefore AH is equal to HA, and therefore H is a normal subgroup of G, right? So this is what theorem कि H is a normal subgroup of G if and only if this thing happen, and this thing means this one. So what we have? तो मतलब मुझे कभी बोल दिया कि you just prove that say K, you saw that K is a normal subgroup of G. सपोज मुझे ये दिखाना है, तो मैं क्या करूँगा अब? One way is what? You saw that AK is equal to KA for all A belongs to G. This is one way. The second way is what? You take one element from K, let K belongs to K, and one element from G, small g belongs to G, and you saw that G K G inverse, जिसको नॉर्मल दिखाना है उसका जो एलिमेंट है वो सेंटर में रहेगा, और जो जिसमें नॉर्मल दिखाना है उसमें से जो कोई भी एलिमेंट लिया दैट विल बी ऑन द बिसाइड एलिमेंट एंड इट्स इनवर्स. सो वॉट एवर दिस एलिमेंट यू सॉ दैट दिस बिलोंग्स टू K. तो आपने ये लिया और ये दिखा दिया. इट मीन्स वॉट? K is a normal subgroup of G, right? K is a normal subgroup of G. Of course पहले ये जो मेरा K है वो subgroup होना चाहिए. Once K is a subgroup, and to show that it is normal, you just saw this. Okay, so we frequently will use this technique to show. तो मतलब जिसमें एक एलिमेंट, जिसको नॉर्मल दिखाना है उसमें से एक एलिमेंट लो, और जिसमें नॉर्मल दिखाना है उसमें से एक एलिमेंट लो, और वो दोनों एलिमेंट की हेल्प से आप एक ऐसा एलिमेंट कंस्ट्रक्ट करो, एंड यू सो दैट दैट टाइप ऑफ एलिमेंट इज इन द सब ग्रुप विच यू वांट टू प्रूव इट इज नॉर्मल, राइट? तो उसमें दिखा दो. तो इसमें दिखाने का कोई मतलब नहीं है जी में. ये तो इट्स ट्रिवियल बिकॉज जी इज इन जी, K belongs to K, K is a subset of G, K in fact K is a subgroup of G. तो ये जो K है वो भी G में है, तो ये सब G, K, G इनवर्स सब G में है, तो इसका जो प्रोडक्ट है वो तो ऑफ कोर्स G में आएगा, बिकॉज G is what? G is a group. So this is trivial thing. So there is nothing special in this. So we need to show that it is in K, right? Okay, so we'll use this result H is normal in G if and only if this thing. So this is what characterization. So now we have two techniques to show. So now we'll further on we'll collect the techniques which gives me or which claims that this subgroup is a normal. तो एक ऐसा हमने एक टेक्निक्स हम कलेक्ट कर ही रहे कि कब में मेरा कोई ग्रुप है वो अबेलियन है ऐसा क्लेम कर सकता हूँ, राइट? तो उसके बहुत सारे रिजल्ट्स है. तो एक अब ये भी नया कॉन्सेप्ट शुरू होगा अब कि कोई मुझे रिजल्ट ऐसा दे रहा है कि ये मेरा कोई सब ग्रुप है, ये ग्रुप का कोई सब ग्रुप है, और ऐसा कुछ हो जाए देन इट इज़ नॉर्मल, देन दैट इज़ वेरी इंपॉर्टेंट रिजल्ट, राइट? सो फर्स्ट रिजल्ट इज़ दिस वन कि यदि मेरा कोई सब ग्रुप का एलिमेंट और ग्रुप के कोई भी एलिमेंट के साथ ऐसी हरकत कर दे दैन दैट सब ग्रुप इज़ नॉर्मल, राइट? सो दिस इज द फर्स्ट रिजल्ट. So now some results and properties. So first one, see, you consider any group G, abelian, non-abelian, finite, infinite, cyclic, non-cyclic, doesn't matter, any group G. Then you consider singleton E, then it is always a subgroup of G, and G itself is a subgroup of G, right? Now you consider any element from singleton E. So there is no choice here, I have only one choice, that is what? Singleton E. So you consider E, you consider any element from here, you consider E, and any element G from G, and you consider G E G inverse. So this is what? G into E is what? It is G, G inverse, and it is identity, so it is belongs to singleton E, right? So it means what? For every element from G and for every element of H, H is singleton E, I have G H G inverse, that is G E G inverse is in H, that is singleton E. So singleton E is what? It is a normal subgroup of G, right? And what happened here? You consider any element say from G, you consider say X, and from here G, and you consider G X G inverse. तो ये G और X G inverse सब G में ही है. So and G is a group, so it definitely it will be in G. So what does it mean? G is a normal subgroup of G. तो क्या प्रूव हुआ? So first observation or first result is for any group G, singleton E is a normal subgroup of G, and G is always normal subgroup of G. Right? For any group G, singleton E and G are normal subgroup of G. Okay. Now second thing. अभी हमने शुरू में डिस्कस किया था, यदि मेरा जो G अबेलियन है, if G is abelian then every left coset is right coset, so by definition every subgroup of abelian group is normal in G. So second, every subgroup of an abelian group is a normal subgroup. Every subgroup of an abelian group G is a normal subgroup in G or normal subgroup of G. Okay, now third thing, so let us say some example of some normal subgroup. मतलब मेरे पास कोई abelian group दे दिया तो उसका कोई भी subgroup normal रहेगा. Now we have to see some non-abelian group. See, if you consider Sn, so it is non-abelian group, right? An is a subgroup of Sn, so it is not only subgroup but it is a normal subgroup of Sn for all n, right? So how we will prove this? So I want to prove this. So you take let F belongs to An and say G belongs to Sn, right? Now you consider G, F, G inverse. So here F and G are what? They are permutation. So now you look at this element G, F, G inverse. So I have to prove that this is an element of An. So if it is element of An, then we are done, right? So my claim, this is my claim. My claim will be what? This is an element of An. So now let us prove this claim. See, F is in An, so definitely F is even. There is no choice for F. F must be even. But G is in Sn, so I have two choices. G may be even, G may be odd permutation, right? So case 1. Suppose G is odd permutation, right? So what about G, F, G inverse? See, G is odd. Let us say O stands for odd. F is even and G inverse. G is odd, so G inverse is also odd. Inverse of odd permutation is odd permutation. Inverse of even permutation is even permutation. We have discussed that thing. So now what we have? Odd into even into odd permutation. So odd into even is what? Odd into even is odd, and odd already I have this odd is there. Now odd into odd is product of these two will be even permutation. Odd into odd permutation is even permutation. So ultimately GF G inverse is what? It is even permutation. So this is an element of what? An. Now case 2. Suppose G is even. So what I have? GF G inverse. So G is even, F is even, and G inverse. G is even, so G inverse is also even. Even into even is even permutation, and here already I have E. So even into even. This product of these two will be even and even. So even into even is again even. So GF G inverse is what? It is even permutation. So it is an element of An. So in any case, GF G inverse is an element of An. So this claim holds. So An is what? An is a normal subgroup of Sn. Now one more example. See, we are familiar with GLNR. This is also non-abelian group, right? GLNR, set of all n by n matrices whose determinant is non-zero, non-singular matrices, set of non-singular matrices. So and we have SLNR. SNLR is a subgroup of GLNR, we know this, but not it is the only subgroup, but it is a normal subgroup. So let us prove. So you take one element, say A belongs to SLNR, and you consider one element, say B belongs to GLNR, right? So immediately determinant of A is 1 and determinant of B will be what? It is non-zero. Right? Now my claim is what? I want to prove SLNR is a normal subgroup of GLNR. So you keep the element of SLNR in center and element of GLNR like this B and B inverse. So my claim is this BAB inverse is an element of SLNR. Okay, so to prove this, what I have to prove, first of all, this should be n by n matrix. And of course, it is n by n matrix. Why? Because A and B both are n by n. So B inverse will be also, determinant of B is non-zero, B inverse exists. So B inverse is also n by n. So B, A and B inverse, all these three are n by n. So its product is n by n. So one thing is clear. Now second thing what I have to prove, the determinant of this thing is what? 1. So determinant, you look at BAB inverse determinant, but by property of determinant we know that it is what? Determinant of B, determinant of A and determinant of B inverse. So it is determinant of B and determinant of A is 1 and determinant of B inverse is what? It is determinant of B inverse, like this. We can do this, right? So this is what? Determinant of B is a number, determinant of B is a number inverse, that is 1 upon determinant of B, and determinant of B is non-zero. So I can talk about its 1 upon determinant of B, and again these two are non-zero numbers, so its product is 1. So determinant of BAB inverse is 1 and it is n by n matrix. So BAB inverse belongs to SLNR. So SLNR is a normal subgroup of GLNR. तो देखो ये हम क्या कर रहे हैं कि वी आर शोइंग दैट दिस सबग्रुप इज अ नॉर्मल सबग्रुप ऑफ दिस वन दिस ग्रुप बाय यूजिंग कैरेक्टराइजेशन एंड डेफिनेशन. ये हम होमोमॉर्फिज्म के यूज से भी दिखा सकते हैं. विल डिस्कस द सेम थिंग विथ द हेल्प ऑफ होमोमॉर्फिज्म, बट here we are just trying to digest the characterization and definition of normal group. Okay, now some more result. Say fifth, a subgroup of index 2, a subgroup of index 2 is a normal subgroup of G. A subgroup of index 2 in a group G, is a normal subgroup of G or a normal subgroup in G. तो मतलब से what this result say, we will prove it. ये रिजल्ट क्या कह रहा है कि मेरे पास कोई ग्रुप है, उसका मुझे सब ग्रुप दे दिया से H इज अ सब ग्रुप ऑफ G, और ये मुझे पता चल गया कि इसकी इंडेक्स 2 है, H की G में इंडेक्स 2 है. सी इंडेक्स 2 होना मतलब क्या कि मैं यदि ये जो H के कोसेट्स फाइंड करूँ तो मुझे इसके 2 ही कोसेट्स मिलेंगे. इट हैज़ ओनली 2 डिस्टिंक्ट कोसेट. इंडेक्स 2 मीन्स इंडेक्स ऑफ सब ग्रुप मीन्स व्हाट? नंबर ऑफ डिस्टिंक्ट लेफ्ट कोसेट्स of subgroup in G or number of distinct right cosets of subgroup in G. तो ये मेरे 2 है, मतलब I have only 2 distinct left coset or 2 distinct right cosets. तो immediately this H will becomes normal subgroup of G. So let us try to prove this. Yes, so let us prove this fifth result. So it's proof. Let H be a subgroup of G and index, that is I of H in G. This is a notation, or you may say index of H in G is 2. So H has only 2 distinct cosets, right? And what I will do, I will show that every left coset is equal to right coset. So you take one element from G. So case 1, से देखो situation क्या है? This is my G, this is my H, and I have considered A belongs to G. So there are 2 cases. A will be outside H or A will be inside H. So let me consider first case, case 1, A belongs to H. तो यदि मेरे पास A belongs to H है, so AH will be same, AH will be same as H because A belongs to H. तो H में से जो भी कोई आप एलिमेंट लेंगे तो उसका कोशेट बनाएंगे, then you will get the same because H is what? You can see this way, A belongs to H, but H is what? It is EH. तो EH मेरा ऑलरेडी एक लेफ्ट कोसेट है, तो इस लेफ्ट कोसेट में से कोई एलिमेंट ले रहा हूँ और मैं यदि कोई कोसेट बनाऊँ AH, then it will be same as EH, but EH is what? H. Similarly, this is what? EH is same as HE also. तो A belongs to HE, so मैं if I consider HA, right, then I will get same as HE, but it is what? H. So what I have? AH is equal to HA. So if I consider A in G, और यदि A मेरा H में से आ रहा है तो उसका जो लेफ्ट कोसेट और राइट कोसेट है बोथ आर सेम. नाउ केस 2, केस 2, सपोज A मेरा किस में है? G माइनस H, मतलब वो G में है लेकिन H में नहीं है, राइट? ओके, सो इन दैट केस व्हाट आई हैव? A does not belongs to H, that is H is what? It is EH, or you may say it is HE, right? So A H में नहीं है तो क्या हुआ? AH is not equal to H. तो मैंने ये जो एलिमेंट है वो जो मेरा एक लेफ्ट कोसेट है उससे उसके बाहर से लिया, तो उससे जो मैं कोसेट बनाऊंगा तो ये दोनों इक्वल नहीं रहेंगे बाय द प्रॉपर्टी ऑफ कोसेट. आइदर टू कोसेट्स आर identical or they are disjoint. So AH is not equal to H, and this AH and H are empty, right? They are not contain any element because they are distinct. And similarly what I have? Similarly HA will also not be H, right, because A is not in HE, and this HA intersection H is what? Empty. Okay, now what I have? Let me remove this portion. Now index of H in G is 2. Index of H in G is 2. So it means H has only 2 distinct left coset, or H has only 2 distinct right coset. So I have AH is one coset and H is another coset, and these two are distinct, and these are the only 2 cosets. So if you consider AH and H, then its union will be what? It becomes G. Similarly, if you consider HA, that is a right coset, and this H is also a right coset, H means HE, this H means EH. So these are also only 2 cosets, right cosets, so its union will be what? It will be G. Okay, so my ultimate claim is what? To show that AH is equal to HA. So now my claim is what? Now this is claim, AH is equal to HA, right? Okay, so let me consider Y belongs to AH. You consider Y belongs to AH. So but AH, so Y belongs to AH union H, इसमें आएगा. AH में है तो इसके यूनियन में आएगा. Now but AH union H is what? It is my G, but G is what? HA union H, right? तो ये Y कहा जाएगा? Y belongs to HA union H. तो इसका क्या मतलब हुआ? Y belongs to HA or Y belongs to H. So Y belongs to, okay, okay, let me write here. It means what? Y belongs to HA or Y belongs to H. Now Y belongs to H is not possible. Why? Because if y belongs to h, then y is already in h. So y belongs to ah and y belongs to h. So ah intersection h is empty, right? If y belongs to ah and y belongs to h, then there is one element in h intersection h, but it is empty. So this thing is not possible. So it means what? Y belongs to h, because h intersection ah is equal to 5. तो मैंने क्या प्रूव किया? y कहाँ से लिया? ah में से किस में दिखाया? ha में. Similarly, you start with y belongs to ha, then y belongs to ha union h. So y belongs to g. So y belongs to h union ah, but then y belongs to h or y belongs to ah. But y belongs to h is not possible. Why? Because if y belongs to h, then y is already in ha, but intersection of ha and h is empty. So y must be in ah. So y belongs to ha implies y belongs to ah. So ha is a subset of ah. So similarly, you can prove that ha is a subset of ah. So therefore ha is equal to ah. तो क्या प्रूव हुआ? केस 1 में यदि a मेरा h में है तो then ah equal to h we had already proved, and if a is not in h but it is in g, then also I have ha is equal to ah. So it means what? Every left coset is equal to right coset, right? So a subgroup of index 2 in a group G is normal subgroup of G. तो मतलब मेरा कोई ग्रुप है, सब ग्रुप है, उसकी इंडेक्स मुझे 2 मिल रही है, देन इट मस्ट बी नॉर्मल. तो देखो इस रिजल्ट से भी आप ये रिजल्ट प्रूव कर सकते थे. An is a normal subgroup of Sn. See, An is what? An is a subgroup of Sn. And what is the order of Sn upon An? Index of An in Sn is what? It is order of Sn upon order of An. Order of Sn is what? N factorial. This one is n factorial by 2. That is what? 2. So index of An in Sn is 2. So An is a normal subgroup of Sn by this result number 5. So that is also the one way. तो यहाँ जो हमने प्रूव किया था वो थियरम या डेफिनेशन की हेल्प से प्रूव किया था. दैट इज अ थियरम, दैट इज कैरेक्टराइजेशन. और ये दूसरा तरीका मिला, ये रिजल्ट. और हम होमोमॉर्फिज्म की हेल्प से भी ये प्रूव करेंगे दिस वन. ओके, see for here I can't apply this result because I can't claim that index of SLNR in GLNR is 2. Yes, one more thing, the converse of this result is not true. मतलब इंडेक्स 2 है तो वो नॉर्मल है, लेकिन नॉर्मल है तो उसका इंडेक्स 2 होना जरूरी नहीं है. फॉर एग्जाम्पल यू हैव लॉट्स ऑफ एग्जाम्पल. सी यू कंसिडर Z10. सो Z10 इज व्हाट? इट इज abelian group. नाउ यू कंसिडर H is a subgroup of Z10 and order of H is 2. तो 2 ऑर्डर का मुझे सब ग्रुप मिल रहा है Z10 में. हर एक डिवाइजर 10 के हर एक डिवाइजर के ऑर्डर का मुझे एक सब ग्रुप मिलेगा Z10 में, राइट? तो अब मैं क्या करता हूँ? व्हाट इज द इंडेक्स ऑफ दिस H इन Z10? इट इज व्हाट? ऑर्डर ऑफ Z10 डिवाइड बाय ऑर्डर ऑफ H. Z10 का ऑर्डर 10 और H का ऑर्डर 2 है, सो इट्स इंडेक्स इज 5. तो ये मेरा जो H है, H इज अ सब ग्रुप ऑफ Z10. तो ये जो मेरा H है वो तो Z10 में नॉर्मली होगा, क्योंकि Z10 इज व्हाट? Z10 इज abelian. सो एवरी सब ग्रुप ऑफ Z10 इज नॉर्मल. तो H मेरा नॉर्मल है लेकिन उसकी इंडेक्स 2 नहीं है. सो कॉन्वर्स ऑफ दिस रिजल्ट इज नॉट ट्रू, राइट? सो दिस इज सिंपल ऑब्जर्वेशन. Index 2 implies normal, but normal it does not implies index 2. Okay, so now 6th one. See, you consider dn. तो ये dn कैसा दिखता था हमने वो. सो dn कैसे दिखेगा? it is of the form x raised to I, y raised to j, where x square is e, y raised to n is identity, and yx is equal to xy inverse, I is equal to 0 1, and j varies from 0 1 to up to n minus 1. So this is my dn, right? Abstract definition of dn. Or if I simplify this, then it is like this. It is e y square, y cube, and so on, y raised to n minus 1, and xy square, and so on, xy raised to n minus 1, right? And this portion is what? This portion is like zn, we had discussed, right? So if you consider, see, h is equal to this one, e y square, and so on, y raised to n minus 1, then this is what it is generated by y, and it is a subgroup of dn, and this is called group of rotation or subgroup of रोटेशन ऑफ dn. ये मेरा रोटेशन का सब ग्रुप है. सी इफ यू फाइंड इंडेक्स ऑफ दिस h in dn, then it is what? ऑर्डर ऑफ dn डिवाइड बाय ऑर्डर ऑफ h. dn का ऑर्डर क्या है? 2n. h का ऑर्डर क्या है? इसमें कितना एलिमेंट्स है? n एलिमेंट्स. सो इट इज व्हाट? 2. So index of h in dn is 2. So h is a normal subgroup of dn by this result. तो मतलब कि क्या हुआ कि dn में जो सबग्रुप मिल रहा है, सबग्रुप ऑफ रोटेशन, दैट इज अ नॉर्मल सबग्रुप ऑफ dn. सो लेट अस राइट दैट थिंग हियर, दैट the subgroup of rotation in dn is normal in dn. The subgroup of rotation of dn is normal in dn. It is a very important observation. मतलब मुझे dn में एक नॉर्मल सब ग्रुप मिल गया. यदि मुझे कोई ग्रुप दिया है, अबेलियन ग्रुप या नॉन अबेलियन ग्रुप, अबेलियन ग्रुप में तो इजी है, लेकिन कोई भी ग्रुप दिया हो, तो ये इंफॉर्मेशन कि उसको नॉर्मल सब ग्रुप मिल रहा है या नहीं मिल रहा. तो देखिए, कोई भी ग्रुप है तो उसको सिंगलटन ई और जी ग्रुप खुद वो तो नॉर्मल रहेंगे हमेशा, लेकिन उसके अलावा कोई मुझे यदि कोई नॉर्मल सब ग्रुप मिल रहा है या नहीं मिल रहा है, ये जो इन्फॉर्मेशन है दैट इज़ वेरी इंपॉर्टेंट इंफॉर्मेशन. विल सी the concept of simple group with this information. So this is what the subgroup of normal, the subgroup of rotation of dn is normal in dn. Okay, now say अभी शुरू में हमने एक एग्जांपल देखा था. We have started with S3 and we have considered one subgroup H1 and 1 2, and it is a subgroup of S3, but H is not a normal subgroup of S3. तो S3 मेरा नॉन अबेलियन था, राइट? S3 इज नॉन अबेलियन. तो मुझे ये नॉन अबेलियन ग्रुप का मुझे एक सब ग्रुप मिला, वो नॉर्मल नहीं था. यदि मेरा ग्रुप अबेलियन है, देन एवरी सब ग्रुप इज व्हाट? इट इज नॉर्मल बाय दिस रिजल्ट नंबर 2, राइट? सो सी ऐसा हो सकता है कि मेरे पास मेरा जो ग्रुप है दैट इज नॉन अबेलियन, बट ऑल द सब ग्रुप्स आर नॉर्मल. Is it true? So let us give you one example that group is not abelian. Group is not abelian, but every subgroup is normal. So this is not happen for every non-abelian group. It happens with some non-abelian group, and that is very interesting group. See, we are familiar with this Q8, right? A group of quaternion, and that is what? It is plus or minus 1, plus or minus I, plus or minus j, and plus or minus k. And we are also familiar with the subgroups of Q8. And what are the subgroups? First subgroup say H1. H1 is singleton 1, singleton identity. H2 is plus or minus 1. Say H3 is plus or minus 1, plus or minus I. H4 is plus or minus 1 plus or minus j. H5 is what? Plus or minus ij, and then plus or minus k. And then H6 is plus or minus ijk. Then H6 is what? Q8 itself. So it has this six subgroups, right? Then this is a singletony, so it is normal in Q8, and this group itself, so it is also normal in Q8. What about this? See, if you see that this is what it is, a center of Q8. I think we have discussed that center of Q8 is plus or minus 1, right? And we'll prove one result. Till now we do not prove that. See, this is a result. You consider G is any group, and center of G, then it is a normal subgroup of G. Center of group is a subgroup of G, that's we know, but in fact it is a normal subgroup of G. We'll see this result, but right now I am using this. This is what it is, a center of Q8, so it is a normal subgroup of Q8. Now if you look at these three subgroups, H3, H4 and H5, then its order is what? Its order is 4. So index of H3 in Q8 is what? Order of Q8 divided by order of H3. So it is what? 8 by 4, and it is what? 2. So index of H3 in Q8 is 2. Similarly, index of H4 and H5 will be also 2. So by the result, subgroup of index 2 is normal. So these are also normal subgroup of Q8, right? तो क्या हुआ? Q8 नॉन अबेलियन है, लेकिन उसका हर एक सब ग्रुप में नॉर्मल है. S3 नॉन अबेलियन था, लेकिन उसका हर एक सब ग्रुप नॉर्मल नहीं था. तो मतलब ये नॉर्मल है कि नहीं, वो जो नॉन अबेलियन ग्रुप है उसके लिए कुछ कह नहीं सकते. उसका हर एक सब ग्रुप नॉर्मल मिल भी सकता है और नहीं भी मिल सकता. और ऐसा कोई नॉन अबेलियन ग्रुप, मतलब ऐसा कोई ग्रुप, नॉट नेसेसरी नॉन अबेलियन, बट द ग्रुप in which all the subgroups are normal, that group is known as Hamiltonian group. That group is known as Hamiltonian group. So every abelian group is what? It is a Hamiltonian group. But we have non-abelian group is also there, which is Hamiltonian group. This is just for information, that the concept of Hamiltonian group. Okay, so let us write this thing, result number 7, that every subgroup of Q8 is normal in Q8. Q8 का हर एक सब ग्रुप Q8 में नॉर्मल है. Okay, now next thing, result number 8. So let me remove this. Result number 8. Actually I have to discuss this before the result Q8, but anyway, so center of the group is a normal subgroup of G. ये मेरा normal है. How? So first of all, center of G is a subgroup of G. First thing, we know this, it is a subgroup. Now I want to prove this is a normal subgroup of G. So you take one element, it is very simple. You take one element from center, say X belongs to or say Z belongs to the center of G, and you take one element G from G. Now you look at GZ G inverse, then I want to prove it is in center. So now Z is what? Z is the element of center, so Z will commute with every element, so Z will commute with G inverse also. So it is G inverse Z, because Z belongs to the center. But G inverse is what? Identity into Z, but that is what? It is Z, and Z is what? It is in the center. So what I have proved? GZ G inverse belongs to ZG. So ZG is what? It is a normal subgroup of G. So it's very simple. See, at the when we discuss ZG, at the same time we have discussed normalizer also, right? So normalizer is what? It is a subgroup of G. Normalizer is a subgroup of G. So can we say that normalizer of A is a normal subgroup of G? No, this is not true, right? In some cases it is true, but in general it is not true. So let us give one example. So let me consider, say G is abelian. So my question is this: is it normal? So let G be non-abelian. कोई भी नॉन अबेलियन ग्रुप ले लो, से S3, D3, Sn for n greater than or equal to 3. So let G be non-abelian group. Let A is equal to E belongs to G. जो एलिमेंट है वो मैं ले रहा हूँ आइडेंटिटी एलिमेंट. नाउ यू लुक एट n of A. So n of A is what? N of A is n of E. N of E means what? Those elements in G which commute with E. G के वो एलिमेंट जो E के साथ कम्यूट करे. कौन कौन सा एलिमेंट है? हर एक एलिमेंट मीन्स G. तो क्या हुआ? Na is equal to what? Na is equal to okay, fine. Okay, Na is G. So Na is here. Na is what? It is a normal subgroup, right? Because Na is what? Na is G. So G is a normal in G. That's fine. तो मुझे क्या चाहिए कि मुझे एक ऐसा एलिमेंट चाहिए A G में से, ये दिस विल नॉट वर्क, राइट? सो Na मेरा नॉर्मल है कि नहीं, मतलब इसके लिए yes, this is what? This is Na is not always abelian. This one is what? Example that Na is not always abelian. But I am interested, Na is normal in G for every A, then answer is no. So I give this exercise, this problem into the exercise that and you will find the same thing from Sn. Sn में से आप Sn you just consider S3. तो S3 में जो 6 एलिमेंट है, तो उसमें से आप कोई भी एक एलिमेंट उठा लो, से n of 1 2 belongs to S3 and you just find out what is this, right? You just find out. Similarly you find out n of if it is not work, then you go for the 1 3, or if it is not work, then you go for the 2 3. So I think one of them will work, and you will find that this will not be the normal in S3. See, S3 के normal subgroup 3 ही है. Which one? Singleton E, A3 and what? S3, right? अच्छा, ये इसका ऑर्डर 1 है, इसका ऑर्डर तो 6 और इसका ऑर्डर 3 है. So if you consider any subgroup of order 2, right, then it will not be normal, right? So you just find out n of 1 2. यदि ये मुझे 2 ऑर्डर का एलिमेंट 2 ऑर्डर का सब ग्रुप मिल गया, then it will not be normal, right? So you just try this thing. So in short, normalizer of element is not always normal in the group, but center of the group is always normal subgroup of the group. Okay, now next result number 9. Let H is a subgroup of G, K is a subgroup of G if either H or K is normal in G, then HK is a subgroup of G. See why this result is important. See, if you have H and K are subgroup of G, then HK may not be subgroup. We had discussed this thing, right? It is what? It is just a subset. So when it becomes subgroup, so we have one result. If G is abelian, then HK is a subgroup of G, and for that we need H and K both are subgroup. If H and K, HK is equal to KH, right, then HK is a subgroup of G. So in that case we have HK is a subgroup of G, but here we have one another condition. If your H and K both are subgroup of G and one of them, H और K, इन दोनों में से कोई यदि एक मेरा एटलीस्ट वन नॉर्मल हो गया G में, तो इसका जो प्रोडक्ट है it will be subgroup, it becomes subgroup. So let us prove this. So proof is very simple. So let H is a subgroup of G, K is a subgroup of G, and without loss of generality I assume that H is a subgroup of H is a normal subgroup of G. Either H और K, दोनों में से एटलीस्ट एक को नॉर्मल होना है, तो मैंने मान लिया कि सपोज H इज नॉर्मल इन G. सो माई क्लेम इज व्हाट? HK is a subgroup of G. So we use two-step subgroup test. So you take let X and Y belongs to HK. तो ये मेरा X कैसा दिखेगा? So X will be H1 into K1 and Y will be H2 into K2 for some H1 H2 belongs to H and K1 K2 belongs to K. Now you find, okay, first of all I have to show that it is non-empty. Of course it is non-empty because H and K both are subgroup. So identity is in H, identity in K. So identity will be identity into identity belongs to HK, and this is what identity. So it is non-empty, right? So it is trivial. So it is to be understood. Now XY. So XY is what? H1 K1 into H2 K2. But I can write this is what? H1. What I want to now prove? XY belongs to where? XY belongs to HK. Yes, I want to prove XY belongs to HK. So how we prove? Okay, fine. So H. Now you consider this K1 K2. K1 H2, and let me consider here K1 inverse into K1 into K2. So I have just inserted here K1 K2 K1 inverse, right? So this is what it is: H1 K1 H1 K1 inverse, and you keep like this K1 K2. So this is what, where it belongs. H1 is an element of H. H1 is an element of H. Now K1 H1 K1 inverse. But see here H is what? H is normal in G. Here H1 belongs to H and K1 belongs to G. K1 is in K, but K is a subset of G. So K1 is in G. So if you consider K1 H1 K1 inverse, then it will be in H because H is normal by our assumption. So this quantity will be in H, and K1 K2, K1 and K2 both are in K, so its product is also in K. So this element and this element, these two both are in H, so its product is also in H. So H, so it no need to write 2 times H, its product is in H, and this is an element of K. So this is belongs to HK. So X into Y belongs to HK. Now X inverse. So X inverse is what? H1 K1 inverse. But that is what? K1 inverse H1 inverse. But here I can write it is K1 into K1 inverse, right? K1 inverse is identity, so I have this one, but this one is nothing but this one. So if I consider like this, it is K1 inverse H1 inverse K1 into K1 inverse, right? See, this K1 inverse H1 inverse K1, it can be look as, let me say, it is K1 inverse H1 inverse, and this K1 is K1 inverse inverse. So if I say K1 inverse is T, then it is T H1 inverse T inverse. Now H1 is in H is a subgroup, so H1 inverse belongs to H, so this is an element of H. And T is what? T and T inverse. T is any element. तो ये जो है मेरा एलिमेंट, इट विल बी इन H. Why? Because H is normal. So ultimately this element is in H. So this element, this belongs to H, and this element belongs to K. So ultimately this belongs to HK. So I have considered two elements in HK, then its product and inverse of element is in HK. So by two-step subgroup test. So by two-step test, HK is a subgroup of G, right? So similarly, if you consider K is a normal subgroup of G and you just manipulate here by H1 inverse, right, then you will get XY belongs to HK, and similarly similar by manipulation of the element of H, here I manipulate by K1 inverse. In that case you have to manipulate by H1 inverse, then you can show X inverse belongs to HK. So again by same argument, HK will be a subgroup of G. So if one of them is normal, then product of two subgroup is also a normal subgroup. So that is one nice piece of information when product of two subgroup is normal, right? Okay. Next, result number 10. If H is a normal subgroup of G and K is a subgroup of G. See what I have considered, H is a normal subgroup of G and K is just a subgroup. I don't know whether it is a normal or not, it is just subgroup. Then H intersection K is a normal subgroup of K. तो मतलब मेरे पास दो सब ग्रुप है, तो उसका इंटरसेक्शन, ये जो दो सब ग्रुप है उनमें से एक सब ग्रुप नॉर्मल है, वो मुझे पता है, दूसरे का पता नहीं, वेदर इट इज अ नॉर्मल और नॉट, आई डोंट नो, बट इट्स इंटरसेक्शन विल बिकम्स नॉर्मल इन अ सब ग्रुप, नॉर्मल सब ग्रुप ऑफ अ ग्रुप which may not be normal, right? So proof is very simple. See, first of all, H is a normal subgroup of G and K is a subgroup of G. तो ये normal subgroup है, तो ये subgroup तो है ही, right? And we know that intersection of two subgroup is subgroup. So H intersection K is what? It is a subgroup of G. But we know that H intersection K is a subset of K also. तो ये अपने आप में ग्रुप है और ये भी अपने आप में with same operation which on K, it is a group. So this one is a subgroup of K. So therefore H intersection K is a subgroup of K first of all. तो ये subgroup तो हो गया. अब मुझे क्या दिखाना है? This one is a normal in K. So you take one element from here and one element from here and let us try to show. So you take let X belongs to H intersection K and say K belongs to K, right? So it means what? Now what I have to show? I want to prove this one is a normal in K. So you take the element of X in center and you look at K and K inverse. So I will show that this element is in the H intersection K. So how can we prove this? So now this is my claim, this belongs to H intersection K. तो कैसे दिखाएंगे? So let us see. See, X belongs to H intersection K. So what I have information here, H is normal in G. H normal है. So it means X belongs to H and X belongs to K. X is in both, right? So K, X is in H and X is in K. So I can say here X belongs to H. So it means what? X, K and K inverse, right? X belongs to K. X H में भी है और X K में भी है. ओके, तो ये आई डोंट, ओके जस्ट यू राइट दिस वन. तो क्या होगा? X, K and K inverse, this will be in H, right? And reason is what? Because H is a normal subgroup of G. ये normal है तो ये जो एलिमेंट बनेगा वो H में आएगा. Because X, it is in H and K is in G. K is in K, but K is a subset of G. And K, X belongs to K. So X K में है. K is already in K. K is already in K. So K inverse is also in K. So X into K inverse. X belongs to K and K is in K. So K inverse in K. So X into K inverse is in K because K is a subgroup and K is already in K. So ये एलिमेंट K का है और ये K is already in K. So K into X K inverse is also in K. And here reason is what? Because K is a subgroup of G. तो ये एलिमेंट K में क्यों आएगा? क्योंकि वो सबग्रुप है. और ये एलिमेंट H में क्यों आएगा? क्योंकि वो नॉर्मल सबग्रुप है. सो अल्टीमेटली K X K inverse belongs to both, that is H intersection K, and that's what we want to prove. So therefore this H intersection K is a normal subgroup of K, right? So this is very important result. One simple example or simple result, but sometime it is asked in MCQ that which of the following is true. Then this is what, if you remember this as a result, then it is easy to select that option. So this is what result number 10. Now let us generalize one result. We had discussed one result that if H is a subgroup of G and index of H in G is 2, implies index of H in G is 2, implies H is a normal in G. तो यहाँ जो इंडेक्स 2 है, it is not true only for 2. See, result is like this. Okay, suppose let G is a finite group. G is a finite group. Finite group. Let P be the P be the smallest prime divisor of order of G. P मेरा है वो स्मॉलेस्ट प्राइम डिवाइजर है किसका? G का, ऑर्डर ऑफ G का. Then any subgroup of G, any subgroup of G of index P is normal in G. देखो इस रिजल्ट की प्रूफ के लिए मुझे साइलोस थ्योरम चाहिए, and we do not have that result right now, so I am not proving this, but I will just write this result and I will explain how to apply this result here, right? So let me write this result number 11. Let G be a finite group let P be the smallest prime divisor of order of G, then any subgroup of G of index P is normal in G. See, let us see one example. Discuss this thing by one example. Let order of G is equal to 75. I don't know whether it is abelian, non-abelian, don't know, but my group is of order 75, right? Let H be a subgroup of G and order of H is set 25. 25 order का मुझे subgroup कोई मिल गया कहीं से, right? Then see here we can write 75 is what? It is 3 into 25, so 3 into 5 square, right? Now if you look at the index of H in G, then it is order of G by order of H, that is 75 by 25, that is 3, right? So index of H in G is 3, and 3 is what? It is the smallest prime divisor of order of G. G के order का smallest prime divisor है. See, here prime divisors of order of G are 3 and 5 only, and 3 is the smallest prime divisor of order of G. और मुझे ये जो H मेरा सब ग्रुप है 25 ऑर्डर का, उसकी इंडेक्स 3 है G में. So therefore by this result I claim that H is a normal सब ग्रुप ऑफ G. मतलब कि G का कोई भी 25 ऑर्डर का मुझे सब ग्रुप दे देंगे, then it will be normal, right? So you can apply this result for any finite group. यदि मेरे G का ऑर्डर से ऐसा कोई हो गया 3 into 5 square into say 7 cube into find us. Let me consider this 5 square into 7 cube. 5 square into 7, let us say 5 square into 7, that is 25 into 7, 375, right? If I consider any subgroup of order set 35 का ले लिया तो क्या होगा? It is what? 5 square into 7 divided by 35. 35 means what? It is 5 into 7. So 5 into 7. So इसकी इंडेक्स क्या होगी? 5. And 5 is what? It is the smallest prime divisor of order of G. So H will be what? Normal in G. मतलब ये 5 square into 7, that is 25 into 7. It is 375. तो मतलब कोई भी 375 ऑर्डर का ग्रुप है, उसका 35 ऑर्डर का कोई भी सब ग्रुप देगा, then it will be normal by this result. So in fact this result is that index 2, right? Index 2, any subgroup of index 2 is normal in G. That is a particular case, or you may say it is a corollary of this one. यदि कोई भी मेरा ग्रुप है और उसकी मुझे इंडेक्स 2 मिले, कोई सब ग्रुप है उसकी मुझे इंडेक्स 2 मिल रही है, if its index is 2, then that 2 is what? 2 will be the smallest prime divisor of my order of G. 2 से छोटा प्राइम कोई मिल नहीं सकता और इंडेक्स 2 मिल रही है, राइट? सो 2 इज द स्मॉलेस्ट प्राइम डिवाइजर ऑफ ऑर्डर ऑफ G. 2 से छोटा प्राइम नहीं होगा, then it is normal, right? So by this result also you can prove that thing. So I am not proving this result, but this is very strong and useful result. So please you remember this result and you start to apply this result wherever it is needed. Okay. Now let us give a new definition which is connected with the concept of normal subgroup. Definition. See, if you have any group G, then singleton E and G, these are always subgroup of G, and these are called improper subgroups, right? They are called improper subgroups. And we have also seen that it is a normal subgroup of G, and this is also a normal subgroup of G. So for every group G, its trivial subgroups are always what? They are normal. So now we define one concept. A group G is called a simple group if it has no proper subgroup. If it has no proper normal subgroup. Let me write here. If it has no proper normal subgroup. मतलब कोई भी ग्रुप है तो उसके ये जो सिंगलटन ई और जी, ये दो तो नॉर्मल सबग्रुप मिलेंगे ही मिलेंगे. यदि इसके सिवा मुझे कोई नॉर्मल सबग्रुप नहीं मिल रहा है, इट हैज़ नो प्रॉपर नॉर्मल सबग्रुप, दीज आर इम्प्रॉपर. ये तो नॉर्मल है ही, इसके सिवा यदि कोई सबग्रुप मिल रहा है देन इट इज़ व्हाट? इट इज़ अ प्रॉपर सबग्रुप, और वो नॉर्मल नहीं होना चाहिए. इट हैज़ नो प्रॉपर नॉर्मल सबग्रुप. देन आई से दैट माई ग्रुप इज सिंपल. Then I will say that my group is simple. So a group G is called a simple group if it has no proper normal subgroup, right? Okay, so see, you consider sorry, it's not. Now it is working. So let us say some results. Which group are simple and which groups are not simple. Try to collect some results. See, you consider prime. So okay, let me write here results and property. Result and properties. First one. See, let G be a group of prime order. Prime order. That is, order of G is P, and P is what? It is prime. तो ये कौन होगा? It must be cyclic. Any group of prime order is cyclic. That is one thing. That is one information. But I do not need require that cyclicity. But see, order of G is what? P. Now let H be a subgroup of G. So it means what? Order of H is what? Order of H will divide order of G, and order of G is P. So order of H is what? 1 or P. मतलब H is singleton E or H is what? G itself. राइट तो मतलब आप कोई भी सब ग्रुप लेंगे देन आइदर इट इज सिंगलटन ई और जी, देयर इज नो अदर सब ग्रुप. मतलब ये जो प्राइम ऑर्डर का कोई भी ग्रुप है तो उसको प्रॉपर सब ग्रुप ही नहीं मिल रहा है. यदि मिलेगा तो वो नॉर्मल नहीं होना चाहिए. यहाँ तो मिल ही नहीं रहा है. सो आई कैन से a group of prime order has no proper normal subgroup. So any group of prime order is simple, right? क्योंकि प्राइम ऑर्डर का ग्रुप रहेगा तो उसके पास कोई प्रॉपर सब ग्रुप ही नहीं है, देन देर इज नो क्वेश्चन अबाउट दैट वेदर दैट सब ग्रुप इज नॉर्मल और नॉट, राइट? सो फर्स्ट रिजल्ट इज व्हाट? any group of prime order is simple. Any group of prime order is simple. Okay, so next what I assume, let G be abelian. Let G be abelian and order of, let G be an abelian group of composite order. So let order of G is say n, and n is what? Composite. ये n मेरा क्या है? Composite. Now it is not prime, it is composite, right? But I will consider one more condition on G, that is what? It is abelian. तो क्या रहेगा कि ये this order of G is a, तो क्या होगा? Say composite. So then there exists one prime, say P belongs to n such that P is prime and P is what? 2 is less than or equal to P and is strictly less than n. P की वैल्यू मिनिमम 2 होगी और वो जो n है उससे छोटा होगा, such that P divides or P divides n. P क्या करेगा? n को डिवाइड करेगा, because n is what? n is composite. See, n is composite means what? It has at least one prime divisor. So let me say that prime is P, right? It has at least one prime divisor and that will be what? It is different from n. So P divides n, but n is what? It is order of G. यदि मेरा प्राइम G के ऑर्डर को डिवाइड कर रहा है, then by Cauchy's theorem I have one element of order, so therefore there exists A belongs to G such that order of A is equal to P. So now you consider H is group generated by A, then this will be the subgroup of G, and order of H is what? Order of H is P. Order of H is what? It is order of same as order of A, and order of A is what? It is P, right? So H is a subgroup of G whose order is P, and P is what? It is strictly less than n. So therefore H is a proper subgroup of G. H is a proper subgroup of G. And G is what? G is abelian. So every subgroup of G is normal. So therefore H is a normal subgroup of G, and it is what? Proper normal subgroup. So therefore H is a proper normal subgroup of G. So therefore G is not simple. G को सिंपल होना है तो क्या होना चाहिए? G को कोई प्रॉपर नॉर्मल सबग्रुप नहीं मिलना चाहिए। और यदि ये यहाँ पे मैंने क्या कर दिया कि G का एक मैंने प्रॉपर नॉर्मल सबग्रुप कंस्ट्रक्ट कर दिया, राइट? सो G इज नॉट सिंपल। तो यदि G मेरा अबेलियन है और उसका ऑर्डर कंपोजिट हो गया, देन इट इज नॉट सिंपल। G मेरा अबेलियन है और उसका ऑर्डर प्राइम हो गया, राइट, देन it is always simple. We have proved that any group of order prime is simple, और prime order कहे तो वो cyclic है, cyclic है तो abelian है, right? So if my group G is abelian and its order is prime, then it is always simple. But if my group is abelian and its order is composite, then it is never simple. So let us write second result. An abelian group of composite order is never simple. It is never simple, right? So that is what result number 2. Now third one, GLNR is not simple. Why? Because SLNR is a normal subgroup of GLNR and SLNR is a proper normal subgroup of GLNR. So SLNR is not, GLNR is not simple. Then fourth one, DN is not simple for n greater than or equal to 2. DN is not simple. Why not simple? See, what is order of D1? What is order of D1? Order of D1 will be 2. So order of D1 is 2. 2 is prime. So prime order का कोई भी है, any group of prime order is simple. So it is prime. So D1 is simple. Now order of D2 is 4. Order of D3 is 6, and so on. But that DN is what? If you consider the subgroup of rotation, then it is a normal in DN. It is true for all DN, right? So this is what? It is a normal subgroup in DN. We have just proved, right? And order of this subgroup is what? It is n. And order of DN is what? It is 2n. So subgroup of rotation is a proper normal subgroup of DN. तो DN को एक proper normal subgroup मिल रहा है. Then it is by definition it is not simple, but it is true for n greater than or equal to 2. So DN is not simple for n greater than or equal to 2, right? So now next fifth one, Q8 is not simple. Q8 is not simple because Q8 में तो क्या है, हर एक subgroup, every subgroup of Q8 is what? It is normal. So and it has 4 proper subgroups and all are normal. So it is not simple. Then sixth one, if you look at A1, A2 and A3, then these are simple. देखो इसमें से कौन सिंपल नहीं है और कौन सिंपल है, which are not simple and which are simple. So you have to keep this in mind. A1, A2 and A3 are simple. Why? What is order of A1? Order of A1 is 1. Actually what is A1? A1 is what? Some author does not define A1, but I am just defining A1. Why? Because A1 is what? It is a set of all even permutation in S1. S1 is what? It is a singleton E. S1 is singleton E, right? तो इसमें से जो इवन परम्यूटेशन है, तो ये जो आइडेंटिटी है वो इवन परम्यूटेशन है. सो A1 इज व्हाट? A1 इज ऑल्सो S1, राइट? और इसका ऑर्डर 1 है और 1 ऑर्डर का कोई भी ग्रुप है, दैट इज व्हाट? इट इज अ सिंपल बिकॉज it has only one subgroup, that is itself. So it has no proper normal subgroup, so it is simple. So order of A1 is 1, so A1 is simple. A1 is simple. Order of A2 is what? Order of A2 is also 1. In fact A2 and A1 are equal, right? So order of A2 is also 1. 2 factorial by 2, that is 1. So implies A2 is simple. Order of A3, 3 factorial by 2, that is 6 by 2, that is 3. So it is prime order. Prime order, every group of prime order is simple. So A3 is simple. What about A4? So A1, A2 and A3 are simple. So 6 result, A1, A2, A3 are simple. Now what about A4? See, A4 is set of all even permutations in S4. So if I consider, see, H is equal to 1, 1, 2, 3, 4, then 1 3 2 4, and then 1 4 2 3. Then this is a subgroup. See, identity, so even permutation, product of two transpositions, so it is even permutation. And this will be what we know, that this is in fact it is a subgroup of S4, and it is like K4. At the time of discussion of the subgroups of S4, we had discussed this thing. This is a subgroup of S4. So S4 has 4 subgroup like K4, right? And one of them is a subgroup of A4 also, and this one is what? It is a subgroup of A4, and in fact it is a normal subgroup. You can prove that. You can prove this. This one is a normal subgroup of A4. तो A4 का order क्या है? It is 12. Order of A4 is 12, and here order of H is what? H is 4. So A4 has a subgroup of order 4, and it is a normal in A4. So A4 has a proper normal subgroup, so it is not simple. So therefore A4 is not simple, because you consider, say, this, let me write K instead of H, this 1, then 1 2 3 4, then 1 3 2 4, and 1 4 2 3. It is a normal subgroup of A4. So it is a proper normal subgroup, so it is not simple. Now what about A5, A6, A7 and so on? So we have this result, Gauss theorem. So you remember this theorem. I will not prove this, we just keep this in mind. Gauss theorem, what it says? An is simple for n greater than or equal to 5. n is simple for n greater than or equal to 5. तो ये जो गॉस ने थियरम दिया वो ऐसा स्टेटमेंट दिया उसने कि an is simple, मतलब if you consider A5, A6, A7 and so on, तो इसके पास कोई प्रॉपर नॉर्मल सब ग्रुप नहीं है, दैट्स व्हाई इट इज सिंपल. तो इफ यू लुक एट व्हाट अबाउट A1, A2, A3 एंड A4, तो ये हमने अलग से बता दिया कि A1, A2, A3 इसके पास भी नहीं है प्रॉपर नॉर्मल सब ग्रुप. सो लेट मी राइट इन दिस वे, A1, A2, A3 हैज नो प्रॉपर नॉर्मल सब ग्रुप, सो दे आर सिंपल, and these are also simple by this Gauss theorem. और ये एक एक्सेप्शनल केस निकला A4. this is what? This is not simple. It has a proper normal subgroup, and that is what? This K, right? तो ये Gauss ने क्या किया कि वैसे वो ये भी ऐसा भी स्टेटमेंट दे सकते थे कि an is simple except n is equal to 4. Means n is simple for all n belongs to n where n is not equal to 4. लेकिन Gauss ने इस ग्रुप को स्किप कर दिया because we can easily observe by just order and using that prime order result and containing just one element like that, right? So this one is very important. A5, A6, A7 up to and so on, it is simple. मतलब इसके पास नॉर्मल सब ग्रुप नहीं. से ये जो हमारे पास ग्रुप आ रहे हैं उसको नॉर्मल सब ग्रुप मिल रहे हैं कि नहीं मिल रहे, कौन से मिल रहे हैं, दैट इज़ वेरी इंपॉर्टेंट व्हेन वी स्टडी द होमोमॉर्फिज्म, राइट? होमोमॉर्फिज्म जब पढ़ेंगे तब इसके सब की ज़रूरत पड़ेगी. तो जब हम A4 का स्टडी करेंगे होमोमॉर्फिज्म में, A4 का कहीं यूज़ आएगा, तो जब उसकी कर्नल हमें फाइंड करनी पड़ेगी तो हमें देखना पड़ेगा कि A4 के पास कौन कौन से नॉर्मल सब ग्रुप है. सो सी A4 हैज़ सिंगलटन E, A4 एंड वन मोर सब ग्रुप लाइक K. It has 3 normal subgroup, but if you look at say A5, then it has only singleton E, and A5 only 2 normal subgroup, no other one, because A5 is simple, right? तो जो ग्रुप मेरे सिंपल है उसके पास दो ही नॉर्मल सब ग्रुप मिलेंगे, सिंगलटन ई एंड ग्रुप इटसेल्फ, एंड groups which are not simple, it has more than these two normal subgroups. Okay, so this is what an is simple for n greater than or equal to 5. Ninth one, you just this is one very nice information. Every non-abelian group, every non-abelian group G of G with order of G is less than 60. 60 ऑर्डर से छोटे ऑर्डर के नॉन अबिलियन ग्रुप, दे आर नॉट सिंपल. एवरी नॉन अबिलियन ग्रुप G with order of G 60 is not simple. मतलब कि मुझे फॉर एग्जाम्पल सपोज आई हैव अ ग्रुप ऑफ ऑर्डर 20, ऑर्डर ऑफ G is 20, order of G is 20 and G is non-abelian. So now my question, whether is it simple? No, it is not simple by this information, right? ये प्रूव करने के लिए थोड़ा एक्सरसाइज करनी पड़ेगी. You just consider 1 to, it is strictly less than 60, so 1 to 59. So you just remove the prime. 1 to 59 में जितने भी प्राइम आ रहे हैं, यू जस्ट रिमूव दैट, बिकॉज जो भी प्राइम ऑर्डर है वो क्या हो जाएंगे, दैट आर अबेलियन. सो उस ऑर्डर के तो मुझे नॉन अबेलियन मिलेंगे नहीं. बाकी के जो बचे एलिमेंट्स इंटीजर्स, उनमें से भी बहुत सारे, फॉर एग्जांपल 15 ऑर्डर के, 15 इज व्हाट, इट इज 3 into 5, so it is p into q, p less than q, p does not divide q minus 1, so it is what, it must be abelian. तो ये भी अबेलियन हो गया, राइट. तो ऐसे ऑर्डर भी निकाल दो. तो बाकी के जो बचते हैं जो ग्रुप्स, उसमें से इफ़ यू फाइंड देन नेवर इट विल बी द सिंपल. तो जो बाकी के जो नॉन अबेलियन ग्रुप बच रहे हैं, उसमें हर एक का कोई ना कोई आपको प्रॉपर नॉर्मल सब ग्रुप मिल जाएगा. सो यू जस्ट रिमेंबर दिस थिंग एज अ इंफॉर्मेशन. एवरी नॉन अबेलियन ग्रुप G with order of G is 60, G is never simple. अबेलियन दे दिया है तो मुझे पता है अबेलियन है, देन एंड इट्स ऑर्डर इज कंपोजिट, देन इट इज नेवर सिंपल बाय रिजल्ट. वो हमने पहले वो रिजल्ट्स और प्रॉपर्टी में कोट कर दिया था. ओके, सो दिस इज व्हाट सम रिजल्ट्स अबाउट नॉर्मल सब ग्रुप. One more result about this normal subgroup. Let me consider this is, let me say 9. Okay, let me remove this one. Let result number 10. Let H1 is a subgroup of G1, H2 is a subgroup of G2. Then H1 cross H2 is normal in G1 cross G2 if and only if H1 is normal in G1 and H2 is normal in G2. यदि मेरा H1 और H2 दो G1 G2 के सबग्रुप है, तो उसका जो EDP, external direct product, it will be normal in its EDP of G1 and G2 if and only if both are normal in respectively G1 and G2. So proof is very simple. So first of all, let me assume that you assume, suppose H1 is normal in G1 and H2 is normal in G2. Now my claim is what? H1 cross H2 is normal in G1 cross G2. So you take one element from here and one element from here. So you take say H1 H2 belongs to H1 cross H2, and say G1 G2 belongs to G1 cross G2. Now I have to solve G1 G2 into H1 H2 and G1 G2 inverse. This should be where? This should be in H1 cross H2. But what is this? It is a G1 G2 into H1 H2. G1 G2 inverse is what? G1 inverse G2 inverse. But this is what? G1 into H1 into G1 inverse, and this is G2 into H2 into G2 inverse. It is just product by definition. But once I consider H1 H2 in H1 cross H2 implies H1 is in H and H2 in H2, and G1 G2 belongs to G1 cross G2. It means G1 belongs to G1 and G2 belongs to G2. But my H1 is normal in G1 and H2 is normal in G1. So G1 H G1 inverse, this will be where? It will be in H. And this will be where? It will be in H2. This will be in H1. So this is an element of H1 cross H2. Right? Why it is so? Because H1 is normal in G1 by assumption. So what I have proved? This composition is in H1 cross H2. So H1 cross H2 is normal in G1 cross G2. Now conversely, now you assume that H1 cross H2 is normal in G1 cross G2, and we will prove this through. So now let me remove this. Now you assume this H1 cross H2 is normal in G1 cross G2. Now my claim is what? H1 is normal in G1 and H2 is normal in G2. So we will prove one by one. First we will prove this one, H1 is normal in G1, and then we will prove H2 is normal in G2, but it will be the similar case. So let us first prove this. So you take, let say H1 belongs to H and say G1 belongs to G1. So implies this H1 comma E belongs to where? It will be H1 cross H2, and this G1 comma E belongs to G1 cross G2, and it is to be understood this E is what? It is the identity of G2 because it is on the second component, but I am not writing E2. It is to be understood. So now H1 cross H2 is a normal subgroup of G1 cross G2 by assumption. So what we have, this this G1E, H1E, G1E inverse. This element is in the center and this element in the side with element and its inverse. This will be in H1 cross H2. Why? Because H1 cross H2 is a normal subgroup of G1 cross G2 by assumption. So it gives me what? It is G1 H1 G1 inverse. G1 E inverse is what? G1 inverse and E inverse, and here E inverse, it will be in H1 cross H2. So this is identity, it is in H2 and this element is in H1. So it is G1 H1 G1 inverse, it will be in H1. right? तो हमने क्या प्रूव किया? You start with H1 in H and G1 in G, then this composition is in H1. So it means what? H1 is a normal subgroup of G1. Similarly, you start with H2 in H and G2 in G2, and you just consider EG2, and you give the same argument. You will prove that H2 is a normal in G2. So similarly, H2 is a normal in G2. So we'll use this result in problem solving. कि मुझे कोई EDP दे दिया है तो और उसका एक सब ग्रुप है EDP का, then it will be in normal in that EDP or not. To examine that, I will just examine whether the first part is normal in first part or not. If it is not, then this EDP is not normal in G because it is if and only if result. See, right? So this is very helpful. Proof is very simple, trivial proof, but it is a very helpful result, right? We'll apply this result in problem solving, and very soon we are will discuss actual problem which are asked in the net and problems similar to that, because now we have enough content to solve the problems, right? So that's what in this lecture about normal subgroups of the group. So we stop this lecture here, and in next lecture we'll see quotient group. Thank you. So we stop this lecture here.